Good everyone, my name is Graphics. If you look at the front of the screen, you will see a question, and the question says that prove by mathematical induction that 1 square plus 2 square plus 3 square plus 4 square plus dot 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 plus n square is equals to n into bracket n plus 1 into bracket 2n plus 1 all divided by what? 6, right? Now, one thing you need to understand about mathematical induction is that what? It is a technique which we use to prove a statement, a formula, or a theorem if it is true for every natural number. Now, when you see a question like this, like the one that is displayed on the screen, right? We have two sides of this equation. We have the left side of the equality sign, which is the left hand side, and we have the right side of the equality sign, which is what? The right hand side. We want to prove that the left hand side is equals to what? The right hand side. So we have it in mind that the left side is the question and the right side is what? Is the answer. And there are three rules, three conditions to show that the left hand side is equal to the right hand side. So we'll check by fulfilling these three conditions. Now the first condition is we prove that n is equals to what? 1, 2, 3, 4, 5, and so on and so forth. But because of time, we always stop at 1 or 2. But wherever you use any natural number of the left hand side, you realize that n is true, n will be true for every natural number altogether. And the second one is n equals to what? Equals to k. That's the second one. So we'll call it by hypothesis, right? So we'll assume that what? We'll say n is equals to k and we'll check if it is true. And the third one is to prove that is to check for n equals to what? K plus 1, right? So let us kick into business. Now, if you look at this carefully, let's start with the first one. For n equals to 1. So what you do is you take the first element at the left hand side, which is 1 square. So if n is equals to 1, so I'll take the first element, I will have what? 1 square. So anywhere I see n, I'm going to put what? 1, right? That's what it means. So I'll take 1 square, that is, I'll take the first element at the left hand side, right? Then anywhere I see n, I'll put 1. So the first element can be anything. It does not necessarily to be 1. Is that okay? It can be anything. So because it's 1, we are fortunate to know that it is 1. But have it in mind. You say n is equals to 1, take the first element at the left hand side. Then in the right hand side, anywhere you see n, you put 1. So let's see that. So I'll be having 1 square is equals to 1 into bracket 1 plus 1 into bracket 2 into bracket 1 close bracket plus 1 all divided by 6. So I have input n wherever I see, I've input 1 whenever I see n. So at the long run, at the left hand side, my 1 square is 1. At the right hand side, we have 1 plus 1 is 2. 2 times 1 is 2 plus 1 is 3, right? Then 1 times 2 times 3 will give us 6. I'll be having what? 6 over 6, which will give us 1, 2. So prove that the left hand side is equals to what? The right hand side. Can you see that? So we say that hence it is true for n equals to 1. Are we communicating? Now let me see prove something to you that you might have not come across before. Let's try another one, another natural number. For n equals to 2. It means you take the first two elements at the left hand side. Then anywhere you see n, you put 2. Are you with me now? I'm just trying this to enhance your understanding. So the first two elements at the left hand side is 1 square plus 2 square, right? Equals to, anywhere you see n, you put 2. we're having 2 into bracket 2 plus 1 into bracket 2 into times 2 plus 1 all together, all over what? Over 6. And we know that 2 plus 1 is 3, and 2 times 2 is 4, plus 1 is 5, right? In the left hand side, 1 square is 1, 2 square is 2 times 2, which is 4, 1 plus 4 is 5. That is the left hand side. And the right hand side, 2 times 3 times 5 is what? We have 30. 30 divided by 6, we have what? 5. So 5 is equals to 5, right? And that is also 1. Is that taken because 5 will cancel out 5. So you can see if you continue like that, you can try yours and tell me in the comment section to see if it is true. If I say for n equals to 3, means you take the first 3 elements at the left hand side. If I say for n equals to 4, you take the first 4 elements at the what? At the left hand side. Then anywhere you see n, you put your 4. So you can try that on your own, and let me know in the comment section if it is true for the element you've tried. Are we good now? For every n, for what n is. Now we'll now move. So we'll be stopping, we'll be restricting because of time and speed. We'll be stopping at n equals to what? 2 or n equals to 1. Any of the two. So let's move to the next one. The second condition is for n equals to what? K. We assume that n equals to k is true. So let's move. So we write 1 square plus 2 square plus 3 square plus 4 square plus dot 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 plus. So when we put in n, I'll put what? K, because we say n is equals to k. So that will be what? K squared. Equals to, anywhere I see n, I'll put k. So we have k into bracket k plus 1 multiplied by 2k plus 1 all over 6. Now since we have unknowns here, right, we're going to term that equation 1. So we're done. We'll keep that aside. Go to the third condition that says for n equals to what? K plus 1 to be true. So what you do is you write out this same guy. K plus 1 means the next step of k. Just like if I have n, if I move to stage 1, I'll have n plus 1. I move to stage 2, I'll have n plus 1 plus 1, that is n plus 2. If I move to stage 3, n plus 1 plus 1 plus 1, that is n plus 3. Are you with me now? So in this case here now, I'll write out everything, which is 1 plus 1 square plus 2 square plus 3 square plus 4 square plus dot 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 plus k square. Then I'll now put what? The next stage, which is what? K plus 1, I'll put square. Are we there? So that is what you do. Equals to, anywhere I see k, I'll put what? K plus 1. All together. So this will now give me, we have, anywhere I see k, I'll put k plus 1. So I'll have, for the first one, k plus 1. Right? For the second one, instead of me writing k here, I'll write k plus 1. Then we already have what? 1 in it already. For the third one, so I'll put the 2k, I'll put 2 into bracket, k plus 1, then plus 1. So in the long run, this will now give me k plus 1, right? And we have k plus 2, because k plus 1 give us, the 1 plus 1 is 2. Then into bracket, I have, open the bracket, 2 times k is 2k, 2 times 1 is 2. Then the 2 plus this 1 here will give us what? 3. So we have 2k plus 3, all divided by what? By 6. Oh, good. Now, as we've done that now, what do you notice? From here to here, right? Look at what I want to write. But 1 square plus 2 square plus 3 square plus 4 square plus dot 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 plus k square is equals to what? K into bracket k plus 1 multiplied by 2k plus 1 all over 6, right? In my equation 1. That is all these guys you see here is equals to all this you see here. So to ensure that there is conformity, right? In both sides, I will now represent this particular values here, this particular series of numbers by what I have here. So instead of me writing 1 square plus 2 square plus dot 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 plus k square, I'm going to write k into bracket k plus 1 multiplied by 2k plus 1 all over 6, right? Then k plus 1 square. Is that taken? Equals to, I'll repeat the other guy down here again, and that's what I have. Can you see that? Now, well, if you look closely, what is common to both sides? We have k plus 1 in both sides of the sign. At the right side of the positive sign, I have k plus 1. At the left side of the positive sign, I also have k plus 1. So when I bring them out simultaneously, so what will be remaining will be k plus 1 into bracket. I'll be left with k inside, and I'll be left with 2k plus 1 inside. All over 6 plus, I remove 1k plus 1 already, so we'll be left with 1, which is k plus 1. Right? Close the bracket, equals to, I have my k plus 1, k plus 2, 2k plus 3 all over 6. Right? Now, after I've done that, the next thing I'll be doing here is to look for what? LCM. So we know the LCM here is 6. Right? Don't forget that we have k plus 1 outside. So inside the LCM is what? Is 6. So if you do that, 6 in 6 is 1. 1 times k into bracket 2k plus 1 will give you k into bracket 2k plus 1. Plus k plus 1 times 6 will give us 6 into bracket k plus 1. Right? Equals to, I repeat the same thing I have here. I repeat it down. That is k plus 1, k plus 2 multiplied by 2k plus 3 all over 6. Now, if I move further, what I have outside is k plus 1 into bracket k times 2k will give you 2k square. K times 1 will give you k, that will be plus k. Plus 6 times k will give you 6k. Plus 6 times 1 will give you 6. Equals to what I still have here, k plus 1, k plus 2, and 2k plus 3 all over 6. Now, what I have here, I am going to collect like terms. So I'll be having k plus 1, 2k square plus k plus 6k will give you 7k plus 6k all over what? 6. Right? So close the bracket, equals to, I still have my k plus 1, k plus 2, 2k plus 3 all over 6. Now for what we have here, I will now factorize 2k square plus 7k plus 6. When I do that, I'll be having two, because that is a trinomial, so I'll be having two different binomial, right? One of them is k plus 1, and the other is 2k plus 3, then all over 6. Is that taken? So you wonder how I got this. This is your quadratic, you use your knowledge of factorization to solve them. So to just help you out, you can easily do this. So we have this. How good? So equals to what I have here, k plus 1, k plus 2, and 2k plus 3. So you see that we've successfully gotten the left-hand side equals to what? The right-hand side. So we'll say hence it is true for n equals to what? K plus 1. So this is what we have here for our example 1. We'll solve series of examples, so you just stay tuned. So if you're finding this video helpful, please don't forget to like the video, subscribe, and also share the video.